Okay, 6.2 is on angle measures in polygons. Again, I wouldn't copy anything but the diagrams if you're writing it down. If you're printing it out, then you're going to want to write a few things inside the diagram. But if you are just copying it into your notes, I would just copy these diagrams in. There's a few things that I want to put inside of here. What do we know about angles in a triangle? Add up to 180. What do we know about angles in a quadrilateral? So let's say we've got a rectangle, 90 plus 90 plus 90 plus 90. What's 90 times 4? 360. So every quadrilateral, they add up to 360. That's going to happen every time. So every triangle is going to add up to 180. Every quadrilateral is going to add up to 360. What does that tell us about the relationship between the number of sides and the sum of its angles? We're going to find that out. The number of its sides, the sum of its number of sides, the sum of its angles. Take a look at this picture. This is a triangle. Triangle has 3 sides, right? And or 3 angles, and they add up to 180. Here's a quadrilateral. Quadrilaterals have 4 sides, right? Or 4 angles and 4 sides, and the 4 of them add up to 360. So a triangle has angles that add up to 180. If you draw one diagonal in this quadrilateral, what do you notice now? You end up with 2 triangles. If I draw one, because from this angle you could only draw one diagonal. You can't go to this side, you can't go to that side, because those are just sides. You can only draw one diagonal in there. So you have 2 triangles. How much do triangles add up to? 180. And how many triangles do I have? Which would be 2 times 180, which is 360. Right? So the reason that the quadrilaterals add up to 360 is because there's 2 triangles inside. Each triangle adds up to 180. So here's a 180, here's a 180. You're going to get your 360. What do you think about a pentagon now? Now inside of a pentagon, let's see. In a pentagon, you can draw 2 diagonals, which would make how many triangles? 3 triangles. So if I've got 3 triangles, and each triangle is 180 degrees, then how much do the angles in a pentagon have to add up to? Well, let's multiply it. 3 times 0 is 0, 3 times 8 is 24, carry 2, 3, 4, 5, it's going to be 540 degrees. Every pentagon will add up to 540, because every pentagon can be broken up into 3 triangles. 3 triangles. So 2 diagonals from the same vertex, you would have 3 triangles. 180 times 3, you get 540. Notice, inside, you've got 5 angles, and they add up to 540 degrees for every single pentagon. It's true for all polygons. So let's think about a formula. Triangle. How many triangles are inside of a triangle? 1. Quadrilateral. How many triangles are inside of a quadrilateral? 2. How many triangles were in the pentagon? So if I have 3 sides, I've only got 1 triangle. If I've got 4 sides, I've got 2 triangles. If I've got 5 sides, I've got 3 triangles. What's the formula? Good. Number of sides minus 2. What is that going to tell me? If I take 2 away from the 5 sides, I'm going to get 3. And what does this have 3 of? Triangles. And each triangle is how much? So you just times it by 1/8. Right? So you're going to take how many sides it has, you're going to subtract 2 to tell me how many triangles are in it, and then times it by 180, and that'll give you the sum of the angles. That'll work for any sided figure. So the next page has the little formula on there for you. Okay, the formula right here. Take the number of sides and subtract 2 and multiply it by 180. Again, if I'm copying down, all I really write down is the formula. And then maybe a couple other little pieces. Where n is the number of sides of the polygon. So if you've got a 6-sided figure, if I've got a hexagon, and I want to know what they all add up to in a hexagon, I take 6 and I minus 2, and what does that give me? gives me 4. And 4 times 180, I'd know they all add up to 720. So it's going to tell me what they all add up to with every single polygon. Go back to here. If I have 5 sides, right, and I subtract 2, that's going to give me 3 triangles that are inside. I subtract 2 to find out how many triangles would be inside that figure. And then I times it by 180 because each triangle is 180. So subtracting 2 gives me the triangles. And then timesing it by 180 tells me how many they all add up to. All right, so here is the little chart that you should look at. I would say just look at it. Unless you printed it, you have it on your paper already. If you don't have it, I wouldn't copy it down because you can get it off the website. But 3 triangles, 3 minus 2 is 1, and 1 times 180 is 180. 4 sides, 4 minus 2 would be 2 triangles in the figure, and you'd have 360. Oh, interesting. 5-sided figure would give you 3 triangles inside, which we just saw on the other page, and 540. 6 would be 6 minus 2, so you'd have 720. 7-sided figure would be 5 triangles, so 5 times 180, they'd all add to 900. N sides just means whatever number you want to plug in. You subtract 2 from it, that's going to give you the triangles, and you times it by 180, that's going to give you the angles. Notice this right here, sum of interior angles. Not the exterior, the ones that are inside the figure. So it's the sum of the interior angles. Okay, just a side note. If all the angles are the same, that means you've got a regular polygon. Then you can find each angle if you want to. Because if you know that they're all the same, and this gives you the total. What if I've got a regular heptagon right here, and I know they add up to 900, and I know they're all the same? So just divide it by the number of sides, and that'll tell you what each angle is. So that's another little formula right here. You just find the total, and then divide it by the number of sides if they're all the same. That'll give you each angle. So if I have a regular pentagon, I can find out that they all add up to 540, and I know they're all the same, so I just divide it by 5, and they're all going to be 108. So first find out what they add up to, and if you know they're all the same, just divide it by that number. And that'll tell you what you've got for each angle. Like I said, this is all going to be on the website. You can always print it later, or you can just watch it and get some of it down later. These are just some formulas that I would have down so you can see them, and maybe always a little example would be good. Let's do a couple practice ones. Let's say we've got this picture up here. What is this called? 1, 2, 3, 4, 5, 6.
Hexagon.
Called a hexagon. How many triangles would be in a hexagon? 4. So if you look at it, there they are. You'd have 1, 2, 3, 4. How did I get 4 triangles? I took the number of sides 6 and I subtracted 2 from it. So 6 minus 2, that told me there were 4 triangles. So that means that each triangle adds up to 180. So 4 times 180. All of these angles have to add up to 720 degrees. That's going to help me when I want to solve it. Because now I can add up all 5 angles that I know. They gave me 5 of them already. You see there was just one of them that was an X. You see there was an X here, but they gave me 5 angles. So I can add all 5 of these plus the 6th one, and I know they have to add up to 720. So that's just an equation that I could set up. Add these 5 together, you get 607. Subtract it on both sides, you get 113 degrees. That means that this angle right here would have to be 113 degrees. 113. Now if I was to add 113 plus all of these 5 angles, they're going to equal 720. That makes it a hexagon. You add it to 720, it makes it a hexagon. Find the sum of the measures of the interior angles of a decagon. Okay, let's do that one together. How many sides does a decagon have? 10 sides. So 10 minus 2 times 180. So how many triangles would be inside of the decagon? 8, because 10 minus 2 is 8. 8 times 180. What's that going to give us? I think 1440. Let's check and see if I'm right. Yep, 1440 was correct. So all I'm doing is taking the number of sides of decagon, subtracting 2 from it, and that's how many triangles would be inside, times it by 180, and you get your total of the inside angle. Okay, what about this one? What kind of figure is that? 1, 2, 3, 4, 5, 6 sides. Hexagon, right? And it's got how many triangles in a hexagon? 4. So what do they add up to? 720. We did one up here that was already here, 720. So let's see what we got here. Let's start at the bottom. 125 plus 147 plus 106 plus 98 plus 143 plus x has to add up to 720 degrees. 1, 2, 3, 4, 5, 6 angles, and they add up to 720. See if you can figure out what that would equal. Use your calculator. Beverly. Hey. 5. There were 2 in the cases, and then 1 in the bag that you gave me, and then 2 in the other bag. Okay. Okay, so 720, what did we come up with for an answer? Did you add all these together?
Yeah.
And then subtract it from 720? Hopefully you got, not showing you the answer. 101. You get 101? Add these up, and then subtract these 5 from 720. You should end up with 101 degrees left. So 101 will be that. So we're looking now, we're switching gears. We've known for a long time that the angles in a triangle add up to 180. That's been the one that we've always learned, and we've seen it a lot of times. Now we're looking and seeing that if it has a certain amount of sides, we can figure out what they're all going to add up to inside, not just 180 because they're not triangles anymore. But we're going to use triangles to help us out. So that's what we're looking at on these. Okay, the next one. Find the area, or each angle in a regular polygon is 140. How many sides does the polygon have? So this time we're going to have to find the end. They gave us the answer. So here's the formula that we need. The n minus 2 times 180 is the total number, and divided by n. If we used this formula, we would get 140 degrees because that's what each polygon has. So there's your formula that you're going to want to write down in there. So if each angle is 140, they want to know what's the n. How many of the sides that are all the same would have angles that would add up to, or would have each angle be 140 in this case. So what would I do first on this? What do you think? How do I solve that? I got to get rid of the fraction. How do I get rid of the fraction? I'm going to multiply both sides by n. It's going to multiply both sides by n because then that's going to cancel out, right? So I multiplied by n on both sides. I'm also going to distribute the 180 to both sides. Multiplied by n to get rid of this fraction. So that means I brought this bottom n over here and made it 140n. So I've got, that's going to give me n minus 2 times 180 equals 140n. I distribute this to get 180n minus 360 because 180 times 2 is 360. Then let's see, subtracted 140 and added 360 to both sides to get 40n equals 360. And then I divided by 40 and I got n is 9. So that means you've got 9 equal sides. If you've got 9 equal sides, what would we call that figure? What kind of nonagon? A regular nonagon. That means it's got 9 equal sides and 9 angles that are all 140. Each angle is 140 degrees, and you got 9 perfect sides that are all the same. That'd be called a regular nonagon. We used this formula right there to figure out the n this time. Normally, we would have the n, and we want to figure out what each angle is. We could also work backwards. If they tell us what each angle is, we can find out how many sides there were, just by working our way backwards and finding the n.
Would it be negative?
Okay, so what I did was I subtracted 140n. That gave me the 40n right here. And then I added 360 to both sides. So that became a positive 360 there. So that was the double step that I didn't really show you in there. All right, so we'll stop there. Got a few left. I'll just call this part 1 of 6.2's notes.